All right, so these are the applications to exponential functions. This is actually a great application because it's something that you will be interested in. Anytime we talk about money, everyone's ears perk up. So what we're going to cover in this particular lesson is continuous compound interest and then just regular compound interest. So I'm going to give you two formulas. Continuous compound interest is A equals PE raised to the RT. So some people call it PERT. For compound interest, it's A equals P times 1 plus R over N raised to the NT. Okay, now let me tell you what all of these mean. The A for both of them is your ending amount. Okay, so in other words, if you have a bank account or a mutual fund or an IRA and you want to figure out what your interest is or how much you're going to have in your account, the A is what you will have in your account at the end of, you know, the interval of time, 5 years, 10 years, 20 years. Okay, so A means the ending amount in both formulas. The P stands for principal, which is your beginning amount. Okay, so beginning amount means what you start with. So let's say you go to your bank and you go, I want to open a savings account. I want to put $1,000 in. So you put $1,000 in, that's your principal, that's your beginning amount. After 5 years, you're going to be able to find out your ending amount. All right, so A is ending amount. P for both of them is beginning amount. The R is your interest rate. All right, so you will be given an interest rate in as a percentage. So the percent must be changed to a decimal. Okay, so let me do this. So if I had a 2% interest, right, and I'm changing it to a decimal, wherever the decimal is, so it's always going to be there, I'm going to move it to the left twice. The reason why I move it to the left twice is because I'm dividing by 100. So remember, a percent is always based out of 100. So if I were to write this, it would be 2 out of 100. Okay? 2 out of 100 is the same as 0.02. So again, moving my decimal twice, I'm going to add in a decimal point. If I had 8.25%, that is the same as 8.25 divided by 100, which is the same as 0.0825. So all I did, when you divide by 100, it just moves the decimal point twice. So when you're working with these applications, you have to change the percent to a decimal. Otherwise, it won't work. All right? Okay. And then the T for both of them is time. This time is going to be in years. Okay? So that's going to be important. So if you have 7 years, your time is going to equal 7. Okay? If you have 7 months, your time is going to be 7 out of 12 because there's 12 months in a year. So that's going to be a huge stone for you to have to not trip over. Is if your time is given to you in months, you have to write it as the number of months out of 12 because there's 12 months in a year. Okay? And then, so that takes care of all of that information. So here, the only one that's different is the N. Now, I believe, let me make sure. I don't think I wrote it down. I believe in my math lab, they use the letter M. Okay, so M is and N are going to be the same thing. So I hope that's not too confusing. But what this is the number of compounds. Okay, so notice we don't use N in our continuous compound, but we do when we have just plain compound interest. So N represents the number of compounds. So here's what happens. When you put money into a bank, all right, as an investment, you get paid interest. That interest is paid periodically throughout the year. So sometimes it's paid monthly. The interest sometimes is paid quarterly. Sometimes the interest is paid daily. Sometimes it's paid weekly. Okay? So all of those interest payments, depending on when they're paid or how often they're paid, will determine the N in your compound interest formula. Okay? So if you are paid quarterly, what that means, oops, should be a Y. What that means is that you are paid 4 times a year. Okay? Every quarter you'll get paid 4 times a year. If you're paid monthly, then that means you're paid every month, so 12 times a year. If you're paid annually, that means you're paid 1 time a year. Semi-annually, twice a year. If you're paid weekly, that means you're paid 52 times a year. Okay? So pay attention when you're dealing with the compound interest formula, pay attention to how often you get paid. Monthly, quarterly, daily, weekly, whatever it is. Because this number will change depending on how often you get paid. Okay? All right, so let me erase this, and then we'll try one. So these aren't too bad. It's just a matter of making sure that you know what numbers go where. Okay? So for instance, let's say you are investing money. All right? So you are 25 years old. You have $10,000 in your pocket. All right, maybe not, but $10,000 that you want to invest. Okay, you want to put it in an account. So your principal is $10,000. That's how much you're going to start with. Okay, your rate of interest is 5%. Okay, so that means you're earning 5% on your investment. You're 25 years old, and you want to take it out when you are 45. All right, so 25 to 45, that's 20 years. And it is being compounded monthly. Okay, so what I'm going to do is I'm going to do both. I'm going to do the continuous compound interest, and then I'm also going to do the just regular compound interest. Okay, the question is, how much will you have at the end of 20 years? Okay, so how much will you have at the end of 20 years? What's your ending amount? That's what you're looking for. All right, so with continuous compound interest, you're going to use this formula, A PERT. Okay, so we're going to plug our values in. We don't know what A is. We do know that our beginning amount is 10,000. E is a number and it will stay there. Okay, so E is part of the equation. The rate is 5%, which when I move my decimal, it becomes 0.05. And the time is 20 years. So because it's in years, I can just put it as times 20. That's a times, not a decimal point. Okay, so there's your formula. There's your values. They're in the right spot. All you have to do is calculate it. So again, you can use your calculator. So with continuous interest, you literally can just plug it straight in. Notice I put parentheses. Super important that you use parentheses. So you're going to go 10,000 times, make sure you use your E value button. So there is an E number on my calculator, and then you can also use e to the x. So I'm going to use my e to the x because it gives me parentheses, 0.05 times 20, and I close the parentheses. So my amount after 20 years, and I'm going to round to the cents, is 27,182.82. All right, so what that means is over the course of 20 years, you earned interest, the interest amount was 17,182. Okay, not bad. It just sat there. You didn't do anything. All you did is invested your 10,000 and it continued to grow. Okay, so you didn't put any other money. It was a single payment. All right, now let's try it with the compound interest. So regular compound interest formula is A equals P 1 plus R over N, all raised to the NT. Okay? So again, we're going to put our values in. We're looking for A. 10,000 is our principal. 1 plus our rate is 0.05. This one, we're compounding monthly, so we are getting paid every 12 months. And then n times t, so 12 times the number of years, which is 20 years. Okay, so again, make sure you put your values in the right spot because it's a formula and because we are doing order of operations. You're going to do what's in the parentheses first. So you can almost do this all in the calculator. I will write numbers down as I go, so in case I push the buttons. So I'm going to start with 0.05 divided by 12, okay, and then plus 1. So it is 1.004166667, okay. That is inside the parentheses. And then I come over here to my exponent, and off to the side, I will do 12 times 20, which is 240. So what that means is I get interest 240 times throughout the 20 years. Okay, I get interest every single month for 20 years, so 12 times 20. Okay, and then I still have my 10,000 out here and still looking for A. So now on my calculator, I still have this 1.004166667. I am not rounding it yet. Don't round until the very end, all right? Because if I round here and then round at the end, now I've adjusted the value too much, okay? So now I'm going to take that, and on your calculator, you can use the hat key. Okay, so this is for exponent. That's one of the keys on your calculator. Or you may have y to the x. If you have y to the x, your y value is your 1.0041667. Your x value is the 240. Okay, so I'm going to raise this to 240. And again, I like to write my values down so that I have some place to go back to if I need to. And then that times 10,000. So my amount is 27,126.40. Okay, so you can see there's a little bit of a discrepancy between these two. It's only off by about $60. This is continuous compound. That means it's continually getting interest. This is, I only get interest once a month for 20 years. So I am going to have a little bit less interest. The thing that you want to watch for is if you're doing both continuous and regular compound interest, these numbers should be close. If you get some number that's astronomical off the charts, then you did something wrong. Okay, so these two numbers, these two values should be very close to each other. And those are the two formulas that we're going to use for 2.5.